This meeting is being recorded.
In Chapter 4, Problem 18, we're given two structures. We're given 2,2-dimethylpropane, and in Section B here, we're given 2-methylpropane. So one less methyl substituent on our propane. And we're asked to predict the energy barrier to rotation by looking down any one of the carbon-carbon bonds. So I've chosen a carbon-carbon bond for us to look down in these bond line structures that are indicated below. And then in the second part of the question, we're asked to draw the Newman projection and compare the staggered and eclipse conformations. So we're reminded that for each eclipsing hydrogen, pair of hydrogens, we'll add 4 kilojoules per mole. And then for a hydrogen in a methyl group, we know that we can attribute 6 kilojoules per mole to that energy barrier to rotation. So let's take a look at part A here. So we're looking down this path here. So we see this carbon first, which has 3 methyl groups, and then this second carbon here would have 1, 2, 3 hydrogens. So let's take a look here. If we were to draw the Newman projection for this, if we did the eclipsed form, that would be how we could predict our energy barrier. So we have 2 methyl groups pointing up in the front here on our front carbon, and then we have 1 methyl group pointing down on our back carbon. For this Newman projection, we're going to have our eclipsing structure. So we have hydrogen, then we have this hydrogen will be slightly below, this hydrogen slightly over here. So this is our eclipsing Newman projection, and we know that for every hydrogen and methyl eclipse, we would have 6 kilojoules per mole. So the total energy barrier to rotation in the staggered conformation would equal 3 times this, or 18 kilojoules per mole. So let's take a look. This was the 2,2-dimethylpropane. Let's take a look at when we only have that 1 methyl group. So we have now 2-methylpropane. So let's look down our line of sight. So we're going to start at this carbon. We'll stop. This is our second carbon here. And again, we want that eclipsing form. We know that we have 3 hydrogens on our second carbon. We're going to have 1 hydrogen here, right, for our front carbon. So let's draw our Newman projection. So the first carbon that we see, we have hydrogen to the right, we have a methyl group to the left and up, and then down we have another methyl group. And the eclipsed second carbon, right, all those hydrogens will be very close. And we see that we have an eclipsed pair of hydrogens here. So that's 4 kilojoules per mole. And then each of these 2 eclipsing structures over here, we have a hydrogen and a methyl. So each of these would be an additional 6 kilojoules per mole. So we do 2 times 6 is 12 plus 4. That gives us a total predicted energy barrier to rotation of 16 kilojoules per mole. And we are asked to compare the staggered to the eclipse conformations. So the staggered would be that much. Oh, I'm sorry, this should be 18 kilojoules per mole. Apologize about that. But this structure in the staggered conformation, the structure would be, that conformation would be 18 kilojoules per mole less, whereas this one, the staggered, would be 16 kilojoules per mole less potential energy.